Shenanigans.
Hey guys, welcome to episode 3 of our game dev tutorial series. I'm Seth from Butterscotch Shenanigans, and today we're going to be talking about obstacles. And over the past couple episodes, we've been putting together the core components to make a simple game. And so far, we've gotten a spaceship that the player can fly around using A and D for inputs. The only actions that the player can take currently are turning left and right, and we have put coins in the game that the player can pick up, and we're also displaying those coins on the screen. So as we discussed earlier on, these are some of the just bare minimum essential components to make a simple game. And at Butterscotch, we really advocate for people to start out by making small, simple games. And I think a good way to sort of think about this is it's kind of like an artist's sketches. So if you want to first start, if you want to become an artist, become a painter or something, you're not going to assume that you'll be able to just paint a giant, perfect painting right out of the gate and sell it. It takes practice, right? It takes sketches and lots of attempts and stuff. And so these small games are basically exactly that thing. So if you're first starting out, you want to make lots and lots of small games. And that is the goal of this tutorial series, is to show you how to think about that. So today we're going to be focusing on obstacles. And so we've got the ability to fly the ship around. We've got turning left and right. The ship in the game moves forward perpetually, and so you just steer it. And you can also pick up coins that are just randomly scattered around. And next we need something for the ship to bang into. And so we're going to put some kind of like an asteroid kind of a thing out in the world. The game is still in a very prototypey state right now. We're just kind of putting mechanics together. And it's definitely not going to be fun, even by the end of this video. We'll get to that a little bit later. So right now we're just kind of putting the pieces together. All right, so let's get on to making the obstacle. So first thing we want to do is make a visual for the obstacle. So we're going to go back into sprites and hit create. And we're going to call this asteroid. And it's probably fine to just leave it 64 by 64. And I'm gonna make the asteroid into a square, because as we all know, asteroids just kind of naturally become perfectly square shaped in space. It's just kind of a general physics thing. And let's pick a good color for these. All right, let's make these asteroids orange. That'll do it. Okay. Orangish, I guess. All right. So this is our SP_asteroid. And we're also going to make an object for the asteroid. And let's double check its collision mask too, to make sure that it's going to work properly. And I'm actually going to kind of tuck the collision mask in a bit, so that the player has a little bit of leeway, so that if they kind of graze past the asteroid, then it'll make them feel like they're super skilled, because they'll just barely miss it. Okay, we're gonna make a new object, and that's gonna be O_asteroid. Give it the asteroid sprite. Boop. And let's just leave it there for now. I'm going to pop open the room, and we're going to drag a couple of asteroids into the room. Put them kind of toward the edges a little bit. Okay. So this is what this looks like at the moment. And again, I fully recognize how hideous this is. We'll fix that a little bit later. All right, so we have no collisions, nothing actually happening with the asteroids. And so let's do that first. So we'll have the player object. Just like how we collided with the coins, we're going to add a collision event with the asteroid. So collision with asteroid. And we're going to use our other command just like before. So we'll say with other instance destroy. We'll probably add some kind of an explosion here or something. So we're just going to destroy the asteroid. right out of the gate. And we're also going to call the function instance destroy for the player. So this is outside of the code block that's inside the with statement. So I'll separate these with comments so you can see. So what's happening here is inside the asteroid instance we collided with, and now that we're no longer in the with statement, we're back inside the player again. So this is going to cause the player to die, and let's just see what this does. So this should be pretty anticlimactic because there's not going to be any explosions, and you're just going to disappear. Boop. So the player now has died from hitting an asteroid, but that's, you know, pretty lame. So generally what I like to do is make a new object in this kind of circumstance that shows sort of like a scoreboard or something at the end of the run. And so let's make a new object, and we'll call it O_end screen. So this is the screen that will display when the player dies. And to give it a nice fade in the create event, we'll add a variable that's called visibility. Oops, let's actually do alpha. We'll start it at 0, and we'll fade all the visuals of this in over a brief moment. And then let's add a draw GUI event. And also in the create event, we want to turn off the interface so that when we draw this end screen, that we aren't also displaying other things on the interface. So again, we'll use a with statement, and we'll say with OInterface. And this is a pretty cool point. Using a with statement, you can refer to an object like OInterface, in which case the with statement will run this code, whatever code is in here, inside all instances of. So if just by chance we had 3 interface objects, then whatever we put in this with statement would actually run inside all of them. So let's deactivate this. So we have a function called instance deactivate object. So this doesn't destroy the instance. This just disables it temporarily. So if we want to turn the interface back on at some point, then we could do that. And the variable ID is a special variable which refers to the instance ID. So you know how in previous episode I talked about how there's a difference between an object and an instance. An instance is a living version of that object that exists in the world. So even though we only have, say, 1 asteroid object, we can have 1,000 asteroid instances. So every one of those asteroid instances would have a unique ID, which is just acquired by using this ID variable. So this little code block here is basically just saying, let's go into all the interface objects and have each interface object deactivate itself. So that way we can turn the interface off when the end screen appears. Next up, we're going to make the alpha go up over time. So we're going to fade in the end screen, and we're going to draw something onto the user interface. So we'll say alpha plus equals, and this is going to be a new trick that we're going to do, which is we're going to take the frame rate into account. So we're going to say alpha plus equals 1 over room speed, which is equivalent to 1 per second. So just to think about the math on this, there's 60 frames per second. Alpha, that means alpha is going to go is going to increase by 1/60th every frame. So after 1 second, alpha is going to be equal to 1. So the nice thing about using this room speed variable is that if you ever change your frame rate, then all of your values remain unchanged. And this is different than what we did in the player object, where in the player object we we just said, you know, turn speed equals 5, move speed equals 6. So maybe we should go ahead and actually fix these up. So our turn speed is 5, but it's actually per second, it's 5 times 60. So let's do, let's see, 5 times 60 is 300 divided by room speed. And move speed is 360 divided by room speed. So now everything is actually in per second values. So it's a little bit easier to understand what's actually happening. Because as humans, we like to think about things in terms of time, not necessarily frames. And later on, we can actually use time values for this. But for now, I think it's helpful to just think about this in terms of how the frame rate relates to time. So that's what this means here. Okay, so let's go back to the end screen. So in the draw GUI event, we are incrementing alpha by 1 over room speed, and just like the step event, the draw GUI event runs every single frame. So that means every frame we're incrementing the alpha. And now we're going to draw something that sort of colors the whole screen. So we're going to do draw set alpha. And by using this function, anything that happens afterwards can inherit this new alpha value that we set. So we have a function called draw rectangle color, and that means pretty much what you'd think is we're going to draw a colored rectangle. And this colored rectangle is going to pick up whatever alpha we set above. And where we're going to draw this rectangle is covering the whole screen. So just like we did in the interface object, we need to figure out the size of the interface. So I'm just going to grab this and pop it over here. Interface height, display get GUI height. Okay, so we want to draw this rectangle to cover the entire interface so that we cover the whole screen. So our X is going to be 0, or Y is 0, because that's the top left corner of the screen. Our X2, so down here we have X1, Y1, X2, Y2. So that's top left corner, bottom right corner, and then they form a rectangle. So our bottom right corner is just going to be interface width, interface height. So that goes from 0, 0 to all the way across and to the bottom of the interface. And the color of this rectangle, let's make it aqua color, just so that we can kind of see it a little bit better. And because it's going to be very bright. And outline argument down here is, if we set this to true, then instead of drawing a filled in rectangle, it'll draw an outline of a rectangle. We want this rectangle to just cover the whole screen so that we kind of block the view. Okay, so what this should do is over the course of 1 second, this should fade in a full screen color. But we still have to actually spawn this end screen object. And so for now, we can just do that inside the player. And we can just say that whenever the player dies, we'll just spawn this end screen. And we have a special event for this under the player object, add event, destroy. So this is code that will run whenever the player object is destroyed. So I'm in the destroy event, I'm going to say instance create depth. It doesn't matter where we put this thing. So we're going to create an instance of the end screen when the player dies. So let's test this out. And you may also notice that I'm going a little bit faster now than I was early on, and so hopefully it's not too overwhelming for anybody, but you know, feel free to pause or go back. It's a nice thing about YouTube is you can just kind of go at your own pace. All right, so I'm going to bang into one of these asteroids, and it's going to hopefully spawn the end screen. So let's. All right, so I hit it, end screen spawned, we're good. I will say that's a little bit overwhelming, right? So for starters, let's make it black. And just like the text, these 4 color arguments work like a gradient. So this is top left corner, top right corner, bottom right corner, bottom left corner of the rectangle. So you could have it, be red at the top and black at the bottom, and it'll fade in a nice gradient. So you can make it whatever color you want. And let's also not obstruct the entire view. Let's just do like a let's cap the alpha at something like 0.5 so that this rectangle is still somewhat transparent when it caps out. So let's try this. Okay, so everything kind of fades. We could probably fade it a little bit more than that, and that way we can draw text on top of this screen that will not be obstructed by what's behind it. So let's see, draw set font. So let's draw the text on here that just says that you died. And then let's also allow the end screen to restart the game if you click or just do anything. So we'll use our regular font, set H align, set V align. So our horizontal alignment, we'll just draw this text in the center and we'll align it vertically in the middle. So here's an important note here. So one of the fundamental principles of programming is don't repeat yourself. And we've already hit a point where we are, in fact, repeating ourselves. We have these 3 lines of code for setting font values. And inside the interface object, we have those same 3 lines of code, right? Font set right here. Let me move this up so we can see it side by side. So this is a perfect situation to create a script that will take care of this for us. And it's really important when you're putting your games together that anytime you see a pattern like this where you're running the same lines of code over and over again, then you think about how to break that apart and turn it into a script so that you can speed your process up in the future. So let's do that. So let's go to the scripts folder, and I'm going to right click on scripts and create. So script is a globally accessible chunk of code that you can pass arguments into. An argument, it can be anything. It can be a string, it can be a number. You could even pass lists and all kinds of other fancy things in. And a script will do whatever code is in there, and then it'll return some value. So we're going to make a script that collapses these 3 lines of code into 1 line of code. So in my script, I'm going to take these 3 lines of code, and I'm going to allow 3 arguments like this. And we're going to use the JS doc documentation to make this work. So it works like this. Actually, first I'll do it without so you can kind of see. So basically what this means is, I need to name the script. We'll call this font set. So what this will do is we can pass 3 arguments into this script when we run font set, and it will set the font to argument 0. It'll set the horizontal alignment to argument 1. It'll set the vertical alignment to argument 2. So let's do that right here. So in the interface, under draw GUI, instead of these 3 things, we're going to do font set, reg, center, top. And this is going to replace these 3 lines of code because inside of font set, that's exactly what we're doing. So you can see how this lines up where argument 0 here, let me collapse this. So argument 0 is what we're setting the font to, font reg. Argument 1 is what we're setting the horizontal alignment to, right there, center. And argument 2 is what we're setting the vertical alignment to, which is FA top. There's one downside to this, which is you may notice, let's say we click on this built-in function, draw text color. Down here, GameMaker shows us all of the arguments that are possible, right? X, Y, string, color, 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 alpha. Now with our own script, we don't have that, which makes it harder to work with, right? So I click up here in font set, and look, there's no guidance down here, which means that if I try to use this script in the future, I may forget what these arguments were, and then I have to look back inside the script and make sure it lines up. Fortunately, there's a way around that, and it's a thing called JSDoc notation. And basically what we do is we preface each line like this, and for every argument we just give sort of a little nickname. So if we do this, horizontal alignment, vertical alignment, oops. So we put these 3 lines in here, and now when we go back and look, then you'll see the little sort of guides that we wrote here appear down below. So now we can reuse this script, and we are perfectly in the clear. Bear in mind that if you're using GameMaker Studio, this has changed from the way that it used to work. So in GameMaker Studio 2, this JSDoc is how this works now. So it's a little bit of a change if you had been using GameMaker Studio before. Okay, so we have our font set script, and we now have our arguments in it, so we know how to use it. And so we'll replace here in our end screen. So that was in our interface object. Now in our end screen, we have the same thing. We have these same 3 lines of code. So we're going to replace them. We'll say font set, reg, center, middle. So that's our font, horizontal alignment, vertical alignment. And now we can draw our text in the center of the screen. So we're just going to say something like, "You died." And we'll do draw text color again. And this will be at right in the middle of the screen. So the X and the Y position will be interface width, half of the interface width, and half of the interface height. Down here, so our string is just going to say, "You dead." Our colors, let's just make this white. And we'll be talking about color a little bit later. We're going to probably do just a whole episode about making your game look good. And so for now, this is just kind of getting things functional. Okay, so in theory, and then last but not least, the alpha of our text. This is the last argument here. Right now we have it set to 1, which means it's just fully visible. But we want that to fade in along with everything else. And since in our end screen object we have this alpha variable that we're increasing over time to bring in the visibility of it, then we can also use alpha as the last argument here, and then that will make this text fade in along with the screen itself. So let's try this out with our fancy new font set script and see what we can do. Okay, I can get my coins, and I'm dead. And you also notice, as we talked about making the interface disappear, so my coins that were displayed up here are no longer displayed. Okay, next thing to do is we want to be able to restart the game after dying. And right now, there's no way to do that. As soon as I'm dead, the screen is just stuck there, and then I have to force quit the game, which is a terrible player experience. So let's go ahead and let's add some instructions for the player and just tell them to press any key in order to restart. So I'm going to take this line here, and we're going to add a new line of text, and we're going to change the vertical alignment of the first line of text
to bottom so that it starts in the center of the screen and then it sits on top of the center of the screen. And then if we change the vertical alignment of the next line of text to top, then that's going to come down from the center of the screen. And so this will just say, press any key. And we can make this a different color, maybe gray or something, to kind of make it, sort of part of the background a little bit more. Okay. I'm going to go ahead and close this interface object, get some clutter out of the way. Okay. So let's test the visuals of that. So I'm going to hit an asteroid. You dead. Press any key. Now, pressing keys does nothing because all we're doing is telling the player to press a key, not actually hooking the keys up yet. And so, last but not least, let's hook up the key press. So in the end screen object, let's add a step event and hit that. And again, the step event just runs every frame, so it's a perfect place to look for key presses and stuff like that. So in the step, just like we did in the player object, let's go back and look. The player object has these keyboard check commands. So keyboard check, D and A, and then that changes the image angle of the player. So we're going to take another keyboard command, but now inside the end screen. So, and the reason that we're doing this inside the end screen is the only time we want to restart the game like this is during this screen. So it would make no sense to put this key press in some other object. So this is where we should put it. So we'll say if keyboard check pressed. So you may notice that in the player we used keyboard check, and now we're using keyboard check pressed. So what's the difference? There's 3 parts to every keyboard event. One is a press, one is a hold, and the other is a release. So keyboard check is the hold. Basically, this returns true as long as that key is being held. Keyboard check pressed only returns true for 1 frame, and that is the frame immediately after the key is hit. So when I press G, then keyboard check pressed will say true if I'm doing this. Then keyboard check pressed will return true, but it'll only return true 1 time until I release the key and then press the key again, and then it will say true again. So we're gonna just check for a keyboard press, and we have a special code called VK any key, which VK again stands for virtual key. And any key is a special code for literally any key. So we just say, if keyboard check pressed, any key, then we're going to restart the room. You could also at this point do a game restart if you wanted to, because there's only 1 room in the game, so restarting the room is basically the same thing as starting the game over. But probably in the future, we're going to have a main menu and a bunch of other stuff. And so we may not necessarily want to send the player all the way back to the main menu when they die. We may want them to just be able to play again. So we're going to do a room restart. So let's try that. Okay, I'm dead. I press a key, and now I'm starting over again. Okay, so there's one final problem that we need to deal with this end screen, which is that since we're checking for a key press as soon as the object is created, then if the player is spamming keys, then they could instantly restart with no real indication. So just to show you, I'm just going to start like spamming J, which is a useless key normally, but I'm just going to be spamming it, and then I'm going to bang into something. So spamming J. Oh, look at that. It restarts instantly, because we're just checking for any key press as soon as the end screen is there. So there's a pretty easy way around this, which is we basically kind of just need a cooldown on this end screen where it'll wait a moment before accepting a key press. So we have this alpha, and the alpha increments over time. So if we basically wait until the screen is fully faded in before we allow a key press, then that'll take care of that. So we're not just going to check for a key press, we're going to also check to see if we faded this screen in enough. So we'll use an AND. So I was saying if keyboard check pressed, any key, but also alpha is greater than equal to 1. Only then will we restart the room. So this will prevent that sort of instant restart spamming nonsense. So I'm going to spam J again just to see. Right. So now we actually have a moment to see the end screen. Yep. So that'll take care of it. Okay. And I'd like to also take a moment to try to make these asteroids a little bit more interesting. Because right now they're just kind of these weird floating squares. So let's take the last little bit of this episode to add some flair to these asteroids and make them seem like they're just a little bit more, more dynamic and more alive. Let's go to the asteroid object. So one of the easiest things you can do is in a game like this is to just change the scaling of things and give things a little bit of speed, give things a little bit of spin, and have them kind of rotate around as they go. So for starters, let's randomize the image angle. So we have the iRandom, which is a function that just returns a random number, a random integer from 0 to whatever you put in here. So this is going to give us just any random number of degrees. So let's first try that. Yeah, so now our asteroids have random angles to them, which is already, it's already a little better. Let's also give them some spin. So we'll say spin speed. This is in the create event of the asteroid, by the way. So let's give them a spin speed, and we could say iRandom range, and let's do negative. Let's see, negative 100 to positive 100 divided by room speed. So again, dividing something by room speed converts that into basically per second. So we're going to go anywhere from negative 100 to a positive 100 degrees per second. And then in the step event of the asteroid, we need to use this spin speed to change the image angle. So I'll go to the step event, step, and this is pretty easy. Just say image angle plus equals spin speed. So let's hit play. All right, so now we have spinning asteroids. And so we did this with the spin is accomplished with 2 lines of code, and the initial starting random rotation is 1 line of code. So this is pretty fast stuff to do once you kind of get the hang of it. So there's 2 more things I want to do. One is I want random scaling of the asteroids, and another is I would like to have the asteroids actually moving around. So let's do that. So let's do fly direction equals random 360, and fly speed is going to be equal to, so they should go pretty slowly. We want these to be kind of just like a little bit just drifting around. So this could be anywhere from 10 pixels per second to 50 pixels per second. And that's probably, that some of them may be too fast. We'll just see, and we can easily just tweak this. So if you may recall, what we did in the player object is we did this length dir x, length dir y, move speed image angle. Hey, this is what we need to do in the asteroids. This is another opportunity for a script. So let's create a new script. Let's call it move in direction. And the player object has this x, y, length dir x, length dir y. We'll close this down. So in our move in direction script, we're going to do this same thing. Argument 0 is our movement amount, and argument 1 is our direction. Move speed, move direction. Okay, so now we have a single script called move in direction that's just going to go ahead and make us move that way. So in the player, let's stitch this back up. So we're going to replace these. Very nice. And let's do the same thing in the asteroid. So the asteroid has a fly direction and fly speed. So in the step event of the asteroid, move in direction. So we say fly direction, fly speed. So now these asteroids should all they'll pick a random speed and a random direction when they are first spawned, and they'll just move that way. So let's try it. Okay, so now they're moving, and the reason that we want them moving is, of course, it makes the game a little more interesting, but also it makes them a little bit harder to avoid because now you have to kind of eye their general trajectory. Okay, and there's another kind of a goofy problem with doing this, which is the asteroids fly off screen and then they're just gone forever. So this kind of relates to what we'll be working on a little bit later, which is spawning of things in the world and also having a camera that follows the player. And so remember, the ultimate goal here is to make a game that's kind of like Roid Rage, where you're flying around in this sort of infinite asteroid field. And so right now, you're just constrained in this little box, and so that's something that we will get at a little bit later. All right, so the last thing to do for the asteroid is scaling. So let's give it a random scale, random range. Let's go just from 0.7 to 1. And we have these special variables called image x scale and image y scale. And the great thing about image x scale and y scale is these are built-in variables that will also affect the collision mask. So this isn't just changing the visible nature of the asteroid, it's also changing the collision code under the hood. So this means it'll still be accurate when we try to bang into it. It'll still reflect properly what the collisions are. So let's do this. Okay, so we've got some range and asteroid sizes. You know what though, this is not really enough variety. So let's take this from random range of 0.4. Let's just go ahead and take these asteroids and just make them a lot bigger normally, so we have a lot more space to work with. So let's go image, resize, and this is going to be 128 pixels. Scale the image. There we go. So now we have an asteroid that's quite large, but that also has more variety in its size. Okay, so now we'll have some pretty dynamic asteroids. So there we have it. So we have the collection of good stuff. We have the obstacle for the player to bump into, which is these asteroids. Whoops, looks like we might need to... Yep, we'll need to update the collision mask. There we go. Always double check your collision masks once you edit sprites. All right, so let's revisit our checklist of things to do. All right, so we have the core components of a simple game. And like we talked about in the first episode, these are the minimum number of things that you need to have in order to have a good game. But we have an interesting problem here, which is we have all the pieces, but our game still sucks a lot. It's not very fun. It's pretty ugly. It just doesn't have a lot of things going for it. And so that's what we're going to start to focus on now, is implementing extra features into the game so that we can just get a lot more mileage out of these different pieces that we have in place and actually make them come together into something that has a lot of replay value, that's a lot of fun, and just has a lot of interesting things going on. So we'll hit that in future episodes. So thank you all for watching, and we'll see you next time.
Butterscotch Shenanigans.